Good morning. Welcome to this Ask the Expert webinar on the new IB DP Maths with author Ibrahim Wazir. Ibrahim will answer your pre-submitted questions during the webinar, but if you have any new questions or need any new clarifications, please feel free to submit these via the questions box in your GoToWebinar toolbar. And I'm now going to hand over to Ibrahim.
Thank you, Catherine. Good morning or afternoon or good day, depending on what time zone you're in. First, thanks to Pearson for providing this opportunity for me to share my experience with you. I'm here not as a representative of the IB. I'm just a very independent and experienced teacher and a former examiner. The views I express are my own views and do not reflect the views of Pearson or any other person or institution. I'm assuming at the moment that all of us had read the syllabi as published by the IB. So I'm not going to go into the details of what the syllabi say. You will have read them. I received some questions that came from you, which I will try to address as I talk. But please don't hesitate, as Catherine said, to ask any questions if I left anything that is unclear. First, just in case you don't know me, I have a few words to tell you who I am, etc. At the moment, I'm theoretically retired from teaching and examining, and I actually taught both at the school and university level, mostly here in Vienna. At school, I was a teacher of math, higher level and standard level for a certain number of years. I don't remember really. I was involved in developing the department's math program from 1986 onwards till I retired from school teaching in 2013. At university, I taught statistics and applied math for graduate business students, and from college algebra to discrete math to statistics and calculus for the undergraduates. I did that for 34 years, and then I stopped in 2017. I was involved with the IB for many years, first as an assistant examiner, then as a deputy chief for higher level, and then lastly as chief for further math. I was involved in 3 cycles of curriculum review, stopped working for the IB in 2006, ran workshops for them for new and experienced teachers, mainly in Europe, but also in Asia and North America. After 2006, I stopped with them and I continued working a few years with In Thinking till 2016. But since 2008, I'm actually working with Pearson on IB math textbooks and enjoying it. Let's start and not spend a lot of time on the other things about the changes. I would like to start with a statement from the mission statement of the IB, where it says the International Baccalaureate aims to develop inquiring, knowledgeable, and caring people. And to this end, they want to develop challenging programs of international education and rigorous assessment. These programs encourage students to become active, compassionate, and so on. These things are, I think you may have read repeatedly several times. The mission statement, as it clearly says, that the IB is not a mere examining board anymore. It is an educational organization that is taking part in shaping future generations. The question that we can ask is that we have a syllabus, and I think the normal procedure in the IB is that the syllabus is written for 7 years. It has a shelf life of 7 years, and then they change it. And now the question is, why do we change it? And the reasons that were mentioned by the IB are listed, as you see here. The low uptake of mathematics, higher level. Like among all math examinees, the higher level students are about 10 to 12% over the years. I question sometimes why would that be considered to be a low percent? Not this is something that is normal for math all over the world. Actually, if you look at universities and so on, how large are the math departments in them? But anyway, that is one of their reasons. They want to provide more choices for students, so this way they have the 4 courses, 2 at standard and 2 at higher level. And the other thing is the IB is always high on this alignment and parity of mathematics within the department, within the diploma, because they want it to look similar to the other subjects. And very low uptake of further mathematics, no matter what they did with the further mathematics, whether they called it advanced or further and so on, the uptake for it was most of the time less than 100 students all over the world. So they just wanted to change that. And the increased emphasis on the use of technology. With this change, actually, it looks like the changes that they are making are not only cosmetic, as it has been done several times before. It looks like they are more serious about living up to this mission statement. Of course, there are a few blips here and there. We may discuss it today or not in the syllabus, but they just want to change that. One point worth mentioning before we go deeper into the syllabus is that this syllabus, and it is a fact that is mentioned in the syllabus itself somewhere, I don't remember really where exactly, that it is not a teaching plan. It is only guiding how you set up your program. In an ideal world, really, you, the teacher, should be little concerned about it. Those who plan your curriculum at school should take care that the program meets the demands of the syllabus. So no one says that you have to teach only what is written, and perhaps that should be only the minimum requirement. No one also says that schools should leave many of the basic concepts till the last 2 years. Like mentioning, for example, matrices. You don't have to wait till the last 2 years to introduce students to matrices. Students can deal with basic matrix operations even from much earlier years on, what I call the middle school. Basic statistics could also be used, but they took care of that in prior knowledge. So you don't have to teach every single thing that is written there. Especially comes to my mind is when they talk about equations of straight lines and so on. I don't think that students are waiting to the last 2 years of their high school career to learn what the equation of a straight line is. Good books also should make sure that they offer you good teaching plan. Great plans like what they have in terms of they improve the philosophy, and they have the more emphasis given to approaches to learning and teaching. This is what is called ALT in abbreviation. Is that in such an undertaking, one can expect that the people or the organization doing this job should have some kind of group of specialized experts who know what the universities want, what the workplace would like the students to be, what are the new theories in teaching and learning are, and so on, and they end up writing this type of syllabus. The weak point that the IB is always hung on is that they want a geographical distribution to be represented. They want teachers from different schools all over the world, etc., to be parts of this. And they choose from applicants, and therefore you have a group of applicants writing this one. With all due respect to everybody taking part in it, etc., in my humble view, this is not how you can write a very unique and homogeneous syllabus. But the syllabus is there, and we have to live with it for 7 years. So there is this approaches to learning and teaching is not new, I think. You have seen it before, but it looks like this time, especially with that toolkit that they actually allocated 30 hours for during the 2 years and so on. It looks like the IB is intent on making sure that some of the items on it, like the thinking skills, social skills, communication skills, self-management, and research skills, etc., are being paid attention to. Of course, they did not invent the wheel. They're not the only ones discovering that thing for that whole thing. So one of the items you could look at would be that with the approaches to teaching, that they want your teaching to be inquiry-based. So stand and deliver days are kind of over, conceptually focused. I don't think this is new to you as teachers. Contextualize, and this is where the applied part come into play. Collaborative, and this is something that perhaps we may not really have paid attention to, but with the way the courses are structured, we may be forced as teachers to really pay good attention to this item. Assessment, of course, is the item on their agenda anyway. I think that, as you know, they're not the only ones who think that doing the math is not only just learning the facts, etc. Even giants like Gauss and Hilbert and so on have said that before. It's not like what Gauss said, it's not knowledge, but the act of learning, not possession, but the act of getting there, which grants the greatest enjoyment. Now let's go back just to remind you that the aims of and approaches to teaching and learning, and this is from the guide, it's to empower teachers as teachers of learners as well as teachers of content. You don't want students sitting and listening only. Empower you to create clear strategies for facilitating learning experiences in which students are more engaged in inquiry and greater critical and creative thinking, and encourage them to develop a variety of skills like problem-solving skills or modeling skills and so on. Now we have the, we're coming into the syllabus itself. As you know, that there are the 2 routes that have been introduced. The one that is inquiry-based approach, and the other one is the application-based approach. This will just influence the way you handle your plans in teaching. The students themselves don't have to really look at this one, but it is you who are going to be deciding how to go on with this thing. We will talk about it a little bit later. The cycle of mathematical inquiry starts with a task to be explored. You don't have to start with the theory immediately. You can explore a task. For example, if you want to teach the Taylor expansion, you don't have to start talking about Taylor expansion straight away. You could start with some examples or activities that introduce approximation functions with polynomials of different degrees and so on, and lead the students into some observations very close to Taylor expansion or the Taylor polynomials. So the cycle of the mathematical modeling is not much different from this one. So you have a real world problem. You look at the different possible models. You choose the model, and in choosing the model, this means that there should be back and forth process a lot. But you choose a model, you try it, it doesn't work. Therefore, you go back and the other models that work till it works for you. Then you evaluate it, and if you're satisfied with it, then you may want, and you're a little bit ambitious, you may want to extend it to something else. This is one of Polia's steps that some of you are aware of. Now let's start with the mathematical analysis and approaches and the analysis, the application and interpretation. Let me call them route 1 and route 2 was unused 2. So the analysis and approaches is the program that is nothing but the present syllabus that is been updated a little bit. Some of the old option material has been integrated into this one, because as you know, there are no options anymore, but it is in general the present syllabus. The relatively new thing would be the application and interpretation, and this is the one that emphasizes the applied nature of the subject and interpretation. And the target students would be different here. As you know from it, I just highlighted some of these things. We may even kind of see a little bit of exaggeration of what they want. It is for the AA, it is the strong ability students with and without technology. And these are the students that would be going in their university studies to engineering, math, physical sciences, and in many cases for economics. As you know, many universities do a lot of math in economics, econometrics, and so on. Enjoying the thrill of mathematical problem solving and generalization. I don't know what percent of students I'm expecting to see doing that. For students that don't have these qualities or attitudes, etc., they may be more leaning to us other than interested in developing their mathematics for describing the world and solving practical problems. And that means that they will be using more technology for it. I think that you could just see that the descriptions are not really completely different from what you have now. Only on the right side with the applications ones, they're just telling you that the technology would be used to demonstrate things that are being shown to them, etc. So to translate whatever is written in the guide, I would say that this is for students who are more quantitatively inclined, whose future studies may possibly include mathematics as a component and are competent and prepared and willing to follow the rigor required for studying the Route 1 syllabus and may appreciate problem-solving situation. And notice here, I'm saying may appreciate problem-solving situation. Not everybody, you cannot really require them. Hopefully you encourage them to appreciate problem solving and see the beauty of mathematics. But that would be, I don't know whether it is the majority. The A and I, or the root 2, the students whose interests are areas in non-mathematical and whose future studies may possibly not include math as a major element. I don't know if there are any subjects that don't really include a little bit of math in it. And they are agreeable to accept results supported by observations, not with proof all the time. The use of technology, unfortunately, I think that we are still behind in the root 1, the AA. It allows the use of technology, not really kind of requires it. Doesn't have to require it, in my opinion, any of them, but it allows it. It should allow it in all papers, not only, but this is my opinion on, not only on paper. This two-tier exam is, in my opinion, educationally not sound, because there should be congruency between experience that the students have on day-to-day practice with the assessment. But whatever the situation is, this is what we have. Paper 1, they're not allowed to use the calculator, but you have to make sure that for the rest of the exams that the students have very good graphing skills on a GDC. Not to mention the other ones, because they're not allowed to use it. Perhaps the other calculators that can do symbolic manipulation and so on could be used for the internal assessment only. For the AI route 2, it makes extensive use of technology, which means on all papers the technology would be required. But saying that it is required, that doesn't mean that they have to really use technology for every problem that they have. Only be very wise users of technology. Use it when it is really efficient to do that. Now we come to the changes that may have happened in terms of the assessment objectives. As you look at, it looks like there is more stress, and I'm really happy about that, on problem solving, that it is central to learning mathematics and involves the acquisition of skills and concepts, and it includes non-routine, open-ended, and real-world problems. Don't be discouraged. They're not going to be surprising students on a whole problem where they give them non-routine or open-ended situations. As you have seen from the sample papers, which we will talk about a little bit later, they may include a few parts of a problem where the student may not really have seen that type of problem before. Communication and interpretation, I think that they have been trying to stress this for the last two curriculum reviews, that the students should not only give a bunch of calculations without any communication. Math is also trying to convince other people of your point and why you believe what is right is right. And as I said before, the technology has to be appropriately and efficiently used to explore new ideas and to solve problems. So inquiry approaches, I think we talked about it before. Now to the general structure. I think it's, you know, you have the two routes. I'm starting from the bottom up, the 30 hours, which are called the toolkit. And this toolkit is still, in my view, misunderstood by many people. Would it be just a couple of hours per week that you spend in class for the toolkit or not? My view and understanding of it is that it is giving you enough room in the syllabus to try to integrate activities that can encourage either modeling or problem solving situations, etc., into the activities you allow your students to do. There's actually a video I liked on the Pearson site where one of our co-authors, Stephen Lump, explains a little bit of how he is using this type of approach in his classes already. So if you think about it, you'll have to think about the present situation with the internal assessment. You have about 10 hours of it. I don't know how many hours you end up spending, especially when it came to explorations, how many hours you end up spending in class. When I was teaching, I didn't really use the 10 hours for that purpose, because if I first introduce the students to the idea of the exploration, that could take 1 or 2 hours maximum, I would say. The rest, and I know that I'm asking here for a lot of your time outside of class, is actually between you and the students. The students are not going to do research when you think it is proper for them to do the research in class. You do research, you do your clear thinking, etc., at a moment when you are in a mood to do so, not at any time when somebody tells you, now you sit down and do your research, etc. So the time, if you end up actually allocating time in class, it's not really used very efficiently by students to sit down and do their research on their exploration. It is meant, these 30 hours are meant to create an atmosphere allowing inquiry, problem solving, and modeling that you may consider as a setup similar to lab sessions, for example, or parts of your teaching hour. It doesn't have to be every day. If you are teaching integrals, for example, you can perhaps at the end of a session or before the end of the session or whenever you choose, give them some activities, having them discover the relationship between area and definite integral, and then you can teach it after that. The other thing that you may look at is that, yes, it is true that they said they allocated 30 hours for this toolkit, and they allocated 60 hours for this and 60 hours for that and 90 hours for this and so on. The question is, how do you think they come up with these numbers? It is an estimate, which means that if you have a group of curriculum committee members made up of 20 people or even more, I think at the beginning and so on, everyone has an opinion of how many hours they would take to teach a certain topic. And they ended up agreeing on a certain number. So what is being suggested to you to spend on it, it is for you to determine. Something that has been allocated 10 hours, you may end up spending 15 hours doing it. But you can save that time from another topic, depending on how your students are actually prepared. And as you see here, for the standard level, I think I should use something here. For the standard level, you have the 60 hours that are common. This is something that you really need to pay attention to, especially with the guides and the TSM that came up. I'm surprised that, in my opinion, ill advice had been given. With the AA, it has been a theory from before, is that the standard level and the higher level, the difference between these two is not in terms of the difficulty, or should not be in terms of the difficulty. It should be in terms of the extent, how much they cover from this in standard level and how much they cover from a topic in higher level. Therefore, in the AA or in Route 1, the standard level being a proper subset of the higher level is well taken and should really be observed, which means that students doing SL should be able to learn in a class that has higher level students in it. There is no issue with that. My issue comes with the AI, with the root 2. I think, as you know, it's not a secret anymore, is that the AI SL, the population are the math studies population that are in it. And those students are a special case in terms of their mathematical preparation. And that's why considering them as part of the higher level in that one is not fair, neither to them nor to the higher level students. So in terms of the common core, you just have to look at it only in terms of the content, on what material to be taught, etc., but not in terms of what approach you take in teaching it. This is a problem for you as a teacher, because that is going to create some kind of tension between teachers trying to organize how the courses are taught, and administration that will also try to save money, especially in cases where the classes are not really large, to justify splitting classes itself. Because as you notice also from the TSM, that there are suggestions that you can put the standard level math studies with the higher level students. And as I said, that would be unfair to both of them. In any case, you go up to the standard levels. They are here separated. In fact, I don't want to mention names, but I think one of the publishers made the mistake of having this core. It's a book for both Root 1 and Root 2 students. And then they separated the second year, you could say, into standard level AA and standard level AI. But it's up to you to judge when you see these ones. So the higher level only, there would be 90 hours extra, and they are not completely different from each other, but they're not included in the SL. And here I'm just highlighting this, that it is mentioned there, and this is the tension that I'm expecting, that it may create some tension with administration, that to allow more flexibility in the way that schools group their students, and that is something that should not really be taken lightly. This one. Now, here are comparisons with the old syllabus, as you notice. Number and algebra with the AA, it has been 9 hours. It is now 19 hours. The higher level, it was 30. Now it is 39. The common core, I marked it here. This kind of table would be available. You either send me an email, I'll give you the email afterwards, or perhaps Pearson can make it available at any time afterwards. Now we come to the assessment, and I think that you'll have to be very careful with these things. So for the AA, I would say not very much difference from what we have now. Don't be really misled with this 80%, 40%, and 40%, and so on. You know that paper 1 is going to be 1/3 the marks, and the paper 2 would be, for the standard level, would be 40% of the grade. the paper 2, 40% and 20% for the internal assessment. This is what you have available at the moment. And as you have seen, and correctly so really, that some questions are common with higher levels. So the sample papers that you have seen demonstrate that to you, is that the same questions are on both. And this is a demonstration of what I said at the beginning, is that the standard level is a proper subset of the higher level in this respect. The AI, the same thing, 80%, 40%, and 40% here, and 20% for the internal assessment. Some questions are common with the higher level. Even on the specimens, they were mentioned there. I really have a question in mind, especially when it comes to universities afterwards. If they see the type of questions that are asked of a higher level student, and they're going to see some 50 marks or so that are common with the math studies students on, that could be a problem. I can't really make predictions for it. The higher level, as you see, that it is a two-tier exam, which you heard me criticizing it, that it doesn't really make a lot of sense. 30%, 30% for paper 1 and paper 2. Paper 2, of course, the students are allowed to use a calculator, and paper 3, they're also allowed to use calculators. And the change in paper 3 is that I think it is more logical this time than before. It's not 4 or 5 questions to be answered in 1 hour. It is only 2 questions that would be given to the student. And the thing that comes to your mind is that, wow, this is too much. If a student messes up on one problem, he or she is going to mess up whole exam. I would say look very carefully at the specimen papers that they gave you. I have a couple of specimen papers also that I can provide you on demand. That the first or the good part of the question are accessible to the student, and they are led to draw the correct conclusion and so on, and they are not open-ended and so on. The last 2 or 3 sections of every question is like that. So if a student really messes up on the last 2 sections, I mean, I hate to say, I hope that they don't, but if it happens, it's not the end of the world. So don't be discouraged. 2 problems are logical to be given, to be solved in 1 hour. Actually, maybe also too much, depending on the problem itself. The same thing for the modeling. In the AI, you have the paper 1 and paper 2. Lucky them, they have technology on both papers. And paper 3 is also made up of 2 questions on modeling. And the modeling here is also like the problem solving. Most of the problem that is given, similar to what you have seen in the specimen papers, will be accessible to the students. The last 2 parts of it or so may depend on a modeling situation that the student can come up with. In essence, I think I looked at the specimen paper, and even that part, the student is more or less given help in developing the correct model. Questions that could come to your mind would be, what happens to the internal assessment? As I said, that there will be 30 hours devoted. I hope that you're not going to be spending them in class just for the internal, for the exploration and so on. The situation with the assessment, etc., is very, very similar to what it was before. The big change is for the old population of the math studies. There are no projects anymore, but the explorations were anyway a steal from them. It is similar to what they have done as a project, so it is not going to be new to them. And the assessment criteria, I think, as math studies teachers, you can even prove me wrong if you want to, that it's not really completely different from what they had before. So everybody is going to be doing an exploration. And the criteria for the assessment for the explorations are still as before, with the two changes. The criteria is still the same for the presentation. Criteria B used to be 3 marks, now it is 4 marks, which would be the mathematical communication. The personal engagement, which is nightmare for many of the teachers, went down from 4 marks to 3 marks. If you ask me my opinion, I would either remove it or just give it even less than that. Reflection, which it still be the same, and the use of mathematics is still the same as before. Now we come to the prior learning, which you'll have to pay attention to only in case you are involved in developing the curriculum structure at your school, or you'll have to give your opinion about it, etc. This means that you'll have to make sure that the topics that are mentioned in the prior learning are really covered before the students come to the last 2 years. In my opinion, I don't know whether some people may not really like this, etc., is that you may also want to include some of the proper topics that the students are studying or are suggested in the syllabus. You may want to include it in the years before that. So here you have a list of them and so on, with a couple of glitches in my opinion, because you don't decide whether students are going to be higher level from the middle school or the middle years program and so on. So everybody has to be doing these topics from before. Middle years program, of course, if you're following the middle years program, it's just open, in my opinion. The old suggestions are not valid anymore, is that the standard would only take you to the standard level, and the other ones take you to the higher level. Students cannot be stamped early on that they are good for higher level or not. You'll have to give them the opportunity to develop over time. And that's why, therefore, they could go anywhere. Now to move on to what I just want to share with you. And as we say here, there are John Dewey. I forgot when he was actually, when he said that, but early in the 19th century, perhaps. We'll have to look at it, and this is why I said I'm not surprised to see that the higher level students would are not really a majority or a good proportion of students. Realistically, we're not really preparing every student to be a mathematician. We teach students to at least prepare them to be mathematically literate. Similarly, we teach students science and languages and art and so on to make them literate. We're not making every student a poet, an artist, or a scientist. In the same token, we're not really making every student a mathematician. So not every higher level student is going to be a mathematician in the end. So that literacy requires what is been promoted by the IB and the ATL thing, or ALT, teaching for conceptual understanding, the developing children procedure literacy. This means communicating and so on, and the competence through meaningful problem-solving investigations, and that is part of the toolkit that you have. Now, what would this require from us as teacher actually is to try to, if we want to address the new changes and live up for the expectations, therefore we have to try to accept some shifts in our roles. And these shifts are suggestions that I collected from literature all over. So you'll have to accept to shift your role from a manager and explainer all the time to a resource person and a counselor. This means that the students can actually do a little bit of explanation when they are given the chance. Activities, you're just demonstrate in front of the students that you're also a problem solver, because if you ask them to be a problem solver, any student to be a problem solver, you better be a good example too. Now we come to your plans for the last 2 years. I have developed how am I going to get that? Anyway, I have developed a list of suggestions of how you will set up your classes. The TSM from the IB suggests for you some ways of organizing it. I really and honestly disagree with some of the models. So the models that I'm suggesting are 1 of 4, depending on the school size, etc., that you have. In an ideal situation, of course, if you have large classes for the final 2 years, then you should have 4 classes with 4 different groups. If your school cannot really have, the size does not allow it, etc., therefore, I suggest that in year 1, you have the AA, which is the root 1 higher level in the same class. This is possible given that it's a proper subset. And for the AI, you leave them in separate classes. Now, how can you handle having the higher level and standard level in the same class? This is where the collaborative atmosphere that the IB is talking about really comes into play. Can we handle it? I'm not giving you a theory, really. I have done that for at least 15 years in my career at school. This means that I can, and you can, divide your class into several groups in 2 different types of organizations, where some of the teaching designed by you, but actually performed by your students. The groups can handle that thing. If you use the grouping in class that some groups are higher level only and the other groups are standard level only, therefore, while the standard level students are busy doing some work, either in explorations or an activity in problem solving or in modeling and so on, you will be spending some time with the higher level students, introducing them to the topics that are not introduced in the standard level. One complaint that you can hear from parents and from students, etc., that you may end up having the standard level students spend more than the 150 hours during the 2 years doing that. It's up to you. You can either send them out, or what's wrong with having them study more? You're not really asking them spending less time in class. You're asking them to spend more time in class. I don't think that anyone can complain about this officially. Only the students and perhaps some of the parents. Year 2, I'm saying if it is possible, you separate the classes. If not, then in the same class. As you notice, the AI, I'm suggesting that they are in separate classes. The third scenario would be the 2-3, which means that the AA higher level and standard level with the AI higher level are in the same class. And you should really use the cooperative or collaborative groups, and the AISL are in their own class. So these are the 2 classes. Year 2 option, it's the same situation as you have seen before. But repeatedly here, I'm saying that there should be 3 classes, and your standard level AI are in a separate class on their own. The 2 classes, this is the last thing, which you hope to avoid. But if you can't avoid, because I think in one of the questions that came, you have such a situation, one of us has this type of situation, then you'll have to do it as I'm suggesting here, that the higher level and standard level of root 1 with the higher level of root 2 are in the same class, and the AISL are in their own class. Year 2 is not much different. I'll get back to this. I just one thing that I just have to mention, as I said, I have seen the models that were suggested by the IB. Model 1 is the ideal one that everybody wants, but I really think that what has been suggested about the model 2 or model 3, I don't really agree with that one at all. If you have any questions, you can post them now. I don't know if you did or not. I'll look at it later. Things that face us as new will have to also live up to the challenge and so on. If you have not done that, perhaps these are my suggestions. And I'm not telling you to do something that I have not really done. So the How to Solve It by Polya, if you have not really read that one as a math teacher, that is a must, and that's why it is a #1. It's a classic, I would say. And the other ones that are new, and they would deal with the theories of mathematical mindset and very good suggestions, etc., will be these 2 books by Jo Boaler. You can also follow her on the internet. Now to your questions. How is the mathematical analysis and approaches SL program different from the current mathematics SL program? The question refers to the syllabus content specifically. The content, as you noticed, that there are many common ideas, and as we spoke before, it is actually the delivery that differs between these 2. So even though they are 2 math SL programs, but should not really be put together. Let's face it this way. Think about it as the present situation. You have 2 math studies, 2 math standard level classes, the math standard level and the math studies. I don't know how many schools do put them together. They are really looked at as different groups. So that's what you'll have to look at. One can say, but it looks like the AI papers and so on would be easier than the AA paper and so on. Here, I mean, we can be a little bit philosophical about it and say that, like the proverb that says that the beauty is in the eye of the beholder, like some people think that something is beautiful because they see it as beautiful. So what is beautiful to one person may really not be that beautiful for another person. Just look at the art for one example and so on. So if you are looking at it as a professional, as a math teacher, knowing both questions, the ones that are asked to standard level and the one to math studies, you may think that one of them is easier than the other. But from the perspective of the student himself or herself, the difficulty that they face is actually comparable. And well, enough said about that one. What will the internal assessment now look like? How will it differ from the current math studies IA, I think I mentioned that before. The internal assessment, there isn't much difference from it. Perhaps the IB and the teachers may have learned more about it, how to handle it, but the assessment criteria are still almost the same, except with the changes that we mentioned before. The math studies, as we said, there is no project anymore. It is only an exploration. Applications SL. Will students ever be required to choose the most appropriate statistical test for a set of data in the sample paper? Well, I would say it is not really expected to be so, as you saw from the sample papers. But to be realistic, you may have an examiner that may choose to write a question like that. But realistically speaking, there aren't many procedures, statistical tests that are been included in the program. So the students should not really have, if they were well prepared, they shouldn't have a lot of difficulty with it. The only difficult situation that we can have is with the sample or the specimen papers that you have seen now. These are written by the curriculum review members that are teachers like you and I, and they are not the ones who are going to be writing the exam paper. The exam paper is going to be written by different groups. Here, by the way, I could mention that the new arrangement looks like there will be 2 examining groups. There are 2 chiefs, one for the AA and one for the AI, and they would be supported by, some of them are just assistant examiners, some of them are teachers to write the exams, but there would be 2 chiefs for this exam. And I think that they're going to be learning from it. What I'm almost sure of is that even the specimen papers that you see now, they may change a little bit because there are some glitches that have to be ironed out. Can a student move from the AAHL to AIHL in case he or she faces difficulties in the AA course? You have to try to avoid that thing. If you notice that a student right from the beginning is not really that strong to be able to do the AA higher level, and depending on their plans, future plans, if they're not going into engineering or math, etc., you may suggest the AIHL right from the beginning. But the move is possible there because the AIHL is actually the safest for you, that you can move to any other course that you want to. The only thing that they may miss would be later in the course when there are some topics that are in the AIHL, like in some differential equations and so on, and some statistics that are not covered in the HL. But I don't think that the AAHL student is gonna ask to change from that course to the AIHL that late in the course. So if it is done early, it is possible. Also, the other way around, it may be possible. If you have a good AIHL student that would like to do the AIHL, and it is still early enough in the program, they can do the move. The other question that I have, which math course can we consider when we're having a small cohort, 10 students, and we cannot afford both? As I said, you just have to, as much as possible, avoid having the AISL student be in the same class with the other ones. It's not fair for them, and it's not fair for the rest of the group. And the combination is suggested in the model that I have given you. Another question would be, teaching a mixed SL and HL analysis class with HL having some extra time every week. I can navigate the topics taught only at HL, such as vectors, but some topics are common to both. How much do you think I will be able to teach the students together, since they will learn at different rates and different levels of understanding? Well, I hope that this is not the case. A standard level student in AA should be able to do the common topics that are common between higher level and standard level. As the IB says, that the difference is not in the difficulty, it is in the extent. So the topics that are not taught at standard level could be taught to higher level students, as I mentioned, either in groups in the same class where the students, standard level students, will be doing something else, or when you meet with them extra. But I don't think it should be a different rate, as you mentioned. What kind of mathematics analysis and approaches students should choose if they want to do engineering studies later? What are the big differences between these two types of math? I think the big difference, I can start with this, is that the AA would be more rigorous. It would require proofs, and the other one would be just depending on technology mostly. But if your student is more likely to go into engineering studies, physical science, from physics into whatever topic is related there, etc., or economics at very challenging university where they do a lot of econometrics and so on. Therefore, it is safe to go to the AAHL course. I wouldn't not risk till there is enough time for the IB and for the schools to learn about the new programs. I would not really risk putting a student in a course that I have question marks about their benefit for their future plan. The last question I have here would be, I would like to know which is the impact in content of pure mathematics, and what happens with statistics and internal assessment in terms of content in the new guides. I think we talked about internal assessment enough, that there is enough of it, unless you mean by doing the exploration using statistics, etc. There is no change. They still have the same attitude, but if the student can show some mathematical understanding of what they are applying, you can go ahead and now allow them to do a statistics exploration like that. The pure math, as we said, especially with the AA, you have more proof, including mathematical induction, that is not included in the AI itself. To just end this talking thing, I would say, if you need to be in touch for any exchange of ideas, if there's anything that I left unclear and you would like to clarify, here's my email. We are also offering a workshop conference, because it runs like a conference, in October. Just visit the site here, and would love to host you. Okay, let's see if you have any question that
Thanks, Ibrahim. We here in Oxford have noted down some of the questions, because a lot of them have been repeated. So if I ask you the questions, and you can answer them rather than you worrying about the looking at the toolbar. Is that okay, Ibrahim?
Okay, fine. Let me hide the picture. Okay.
So firstly, this was a question for us at Pearson. There were quite a few questions about whether the session is being recorded and how it can be accessed. So yes, we've recorded this session, and we'll send the recording and the slides as well to everyone that's registered. So please look out for an email next week from us. And now moving on to some more math-specific questions. So there are a couple of questions about word solutions and also GeoGebra and any GDC support. So can you tell us a bit about those, whether they will be included?
Included where, in the exam or? on
No,
the
so
books?
whether the books will have word solutions, GeoGebra, and extra GDC support.
Well, I think, as many of you know, that we finished the writing of the books by the end of 2018, and what we were going through up till now would be making sure that they're free of any errors, and they're top quality to go to you. And among the other things that we're doing would be working on solutions. Detailed solutions of all the problems that are in the book will be available. I think, Catherine, you can tell them by September or something like that, all the solutions will be available. We have a group of teachers from you, perhaps some of you are in this webinar too, that are involved. We have, I think, about 20 teachers that are involved in writing the detailed solutions. So answers are available at the end of the book to every exercise, and solutions, detailed solutions would be there. In terms of the use of technology, there will also be on the accompanying site that is connected to the e-text, I think, there will be GeoGebra support. Perhaps that may include some TI Inspire, I'm not sure about that. But there will be also videos concerning the GDC use. It's mostly it is the KGO. I hope I answered the question.
Thanks, Ibrahim. We've had another question about the teaching approach. I'm not sure if you covered this. Someone's asked, how different is the teaching approach for AA and AI? Is it just the content that's different, or does the teaching approach also need to change?
In my humble view, etc., it's not only that difference between AA and the AI. The difference in the approach should be in both of them, the AA and the AI. The old times of standing the whole time and delivering the information as the sole source of information is not for the teacher anymore. The students have to be partners in this learning process. The best thing that a student can learn, and I know this from experience, as a student, as a teacher, is the things that they kind of, quote unquote, discover on their own. Let them discover, let them guess, discover that they made a mistake. And as Joe Bowler says, mistakes are a must to learn, not only math. So making mistakes, correcting their mistakes, etc., and discovering would be a good idea. So whether it's AA or AI, the teaching approach has to be different. And that's why I am really suggesting these cooperative learning groups. Like if you set up your classes in a cooperative learning group, you divide your classes into groups that are mixed ability groups, where let's suppose that every group is made up of 4 students. You put the weakest in them and the strongest and so on. And you have activities where they can discuss, explain to each other, and it will be much better for both parties. The weak student will have the courage to ask a question in his or her small group because they're not going to be kind of exposing themselves to the whole class. It's a group that they are working with day in, day out, and the student that is strong, etc., it is a test for their understanding, because the best time you understand something is when you explain it to someone. And that's why, therefore, the change will be in both. For the AA, you will have to take part in trying to create activities for them that focus on proof, on problem-solving situations, on discovery approaches, and so on. And the other one would be including the use of technology efficiently and modeling situations. Sources, yes, are still not very abundant, but you can find them. One of your sources would be the old portfolio activities. If you haven't had many of these portfolios, I'm sure that a lot of experienced teachers around will provide you with some of these old portfolio activities. Yes, that was the answer for it.
Thank you. So there's been a few questions about topic order. So somebody said, for example, we try to start with the Common Core content for all classes, but which topic would be a good one to start with? They've asked if it should be functions or maybe number and algebra.
Well, number and algebra, I would say. And the best thing, I mean, it looks like marketing here, would be take our books and follow the order, because we wrote them as teachers, and as one of the teachers using them, it is the book that writes the way you teach. So I think it would be better to start with number and algebra.
Okay, thank you. And when is the best time to introduce the internal assessment? The person that asked the question thinks that they introduced it too early and they gave their students too long. So what's your opinion on that?
I'm glad that it says my opinion, because it's only my opinion. I usually, during the portfolios and during the explorations and so on, I used to give more than one. One that I sent to the IB, and the other one is only a practice. So if you want to start early on, because an exploration that is good to send to the IB and have it evaluated by the IB, etc., early on really may not be appropriate for that thing, because the moderators may really mark it down for you. Give it as experience for the students and so on. And with these 30 hours of toolkit that they mentioned, you have an opportunity to do just that. Give them activities, semi-exploration and so on, introduce them to the idea early. So when the exploration comes, it should not be a surprise to the student, because they would have learned how to do a little bit of research. They would have learned how to communicate the math, how to present their work, etc. Even I could even go as far as saying, have students do presentations in class about the topic of interest to you. Like, you can choose from the syllabus a topic that's your students, and if you use groups for that purpose, then use the groups to do the presentation. You take a topic and have them introduce it. Yeah. I hope that I answered that question. Mm-hmm.
Thank you. There's been a few questions about the books specifically. So can you please summarize what changes we've made to the new books compared to the old books?
Well, the first thing is with the AA, those books, of course, are comparable to the old ones. We introduced the topics that had not been included in the old syllabus, like a little bit of differential equations. For example, we introduced it in the new book, and some of the topics that were not included were included this time. We changed some of the questions that were done before. We took all the old solutions, because if you're familiar with the book, you notice that some of the old solutions were, I'm sorry, we didn't write them, so don't blame us for it. Somebody wrote them, they were wrong. So these have been fixed and expanded a little bit more. More reference is given to the use of technology, but there you'll also have to notice that the previous editions of the book perhaps put so much detail on calculator commands, and as you notice that in terms of calculators change the next day after you write something, so they were a little bit outdated. It is only a hint given to the students that they should be using their GDC, and a sample of what the output is was given. And as I said, the problem sets were updated to reflect any new IB type of questions. So if we did not put directly IB questions themselves, but we put questions that are similar to IB questions. Remember that many of us are examiners ourselves, so we did write new questions to address the new syllabus. This is for the AA. For the AI, they were written almost from scratch, and we have a group of authors that are very well established that took part in it. and they're kind of brand new. So that would be the answer to this question.
Thank you. And how do the books support the paper 3 and the toolkit?
The toolkit and the paper 3, etc. You really don't want a book to just tell you how you do it. As you noticed from the discussion that we had, is that the toolkit is a change in the way you, as a teacher, handle how the class is being run, etc. You can choose in every set of questions that we included in the book. You can choose the last few questions in every set, and you could use them as a setup for an inquiry-based activity that could lead them to something like a paper 3 question, or in the AI books into a modeling one. Sorry, can you repeat, other than the paper 3 and that one? So that would be it, yes.
You answered it. There's been a question about how best to teach modelling. So should they introduce various functions before introducing modelling tasks, or should they take a spiral approach, function by function?
I love the spiral approach, really. But if you use our books, there is, in each one of them, we really dedicated a whole chapter either for the standard level or for the higher level that is just designed for the modeling approach. I think it is chapter 6 in the standard level and chapter 9 in the higher level. I just don't remember it exactly. But
okay. Oh, sorry. Yeah. No, you continue.
You don't have to. Yeah, you don't have to just specifically for that purpose teach it. You don't start teaching the modeling as modeling right from the beginning. You create that atmosphere for modeling by posing questions to your students early on.
Okay, so there's been a question about calculators. So the question is, do you believe calculators like the TI Inspire are better suited to the new courses than the old TI 84s?
This is a tricky question. I don't know, but don't quote me, please. I don't think that the TI Inspire, many people disagree with me, etc., is a must. No, the TI 84, and I think Texas Instruments wanted to get rid of them, but they discovered that many teachers are hanging on to them, and that's why they produced a new TI 84, 84C plus or something like that. So it is good enough for it. So I believe that the calculators are tools to be used to enhance the teaching and learning of math, and not to really take a lot of time to learn them ourselves. And that's why I'm not too much for the Inspire. I'm de-inspired by it.
Okay, do AA students have to solve log equations analytically? The person says it's not clear from the syllabus because 2.1 does not specify types of equations. What is your opinion on this?
You know, to be on the safe side, and that's why I'm saying that the guide should not really be taken as a teaching guide, etc. To be on the safe side, an AA student should be able to reason and argue when they can, and it does not really involve a lot of calculations and the waste of their time, etc. They need to know how to work on that. So rather than just resorting everything to the calculator like it is done in the AI, so an AA student should be able to do it.
Okay, thank you. I think we've answered most of the questions. We, as I said, we'll send out next week. We'll send out an email with the recording, the slides, and also an FAQ document. So if we haven't answered your question, then please look out for that email, as it will be answered. For example, there's some questions about IGCSE versus MYP, so we'll include those questions in that document. So for now, thank you very much to Ibrahim for presenting this webinar, and thank you to everybody who joined and asked questions. And if you do have any further questions, then Ibrahim's email address will be in the email that we send out, so you can get in touch with him. So thank you very much.
Thank you.